Imagine this. After 7 months in deep space, after surviving solar storms, cosmic radiation, and total isolation, the first human crew finally sees Mars fill their window. It looks calm, silent, beautiful, almost welcoming. But Mars is actually one of the most dangerous places in the solar system to land a spacecraft. Not because of rocks, not because of dust storms, because of its atmosphere. It's thick enough to burn you alive, and thin enough that parachutes barely work. In fact, using normal landing technology, a human-rated Mars spacecraft would hit the surface at the speed of a crashing airplane. Today, we're going to follow the final 7 minutes of a Mars mission, the most terrifying phase of the entire journey: entry, descent, and landing, and the problem engineers quietly call the Mars landing paradox. And if you enjoy cinematic space documentaries like this, consider subscribing. This series is following a complete human journey to Mars step by step. Why Mars is so hard to land on. Here's the strange part. Landing on Earth is easy. Landing on the Moon is also manageable. Mars is harder than both. Why? Because Mars sits in the worst possible middle ground. Earth's atmosphere is thick, it slows spacecraft naturally, heat shields plus parachutes work beautifully. The Moon has no atmosphere, so you simply use rockets all the way down. Mars gives you neither option. Its atmosphere is only 1% as dense as Earth's. That sounds harmless. It isn't. When a spacecraft arrives at Mars, it's traveling about 21,000 kilometers per hour. At that speed, the air in front of the vehicle compresses into plasma hotter than molten lava over 1,500 degrees Celsius, so you absolutely need a heat shield. But then a second problem appears. The air is too thin to slow a heavy spacecraft enough. Parachutes deploy, and the vehicle barely decelerates. Instead of gently descending, it continues falling at supersonic speed. This is why engineers say Mars gives you just enough atmosphere to burn up, but not enough to land. The 7 minutes of terror, NASA calls this phase the 7 minutes of terror, because once it begins, mission control can't help anymore. Mars is up to 20 minutes away by radio signal. If something goes wrong, everyone on Earth will only find out after the crew is already dead. So everything must happen automatically. Let's walk through it. Entry, hitting the atmosphere. The spacecraft approaches Mars and hits the atmosphere at Mach 20. Immediately, fire surrounds the capsule. The crew experiences 3 to 4 times Earth's gravity, pressing them into their seats. Outside the windows, the sky turns from black to glowing orange plasma. For several minutes, communications black out. No contact with Earth. The astronauts are completely alone. The heat shield absorbs the energy, literally burning away layer by layer. But here's the critical moment. The vehicle must enter at a perfect angle. Too steep, it burns up. Too shallow, it skips off the atmosphere and is lost into space forever. The safe corridor is only a few degrees wide. They are essentially threading a needle at interplanetary speed. Supersonic parachute and why it's not enough after slowing from 21,000 kilometers per hour to about 1,600 kilometers per hour. The spacecraft deploys a parachute. This is not a normal parachute. It's the largest supersonic parachute ever built, wider than a basketball court. It opens at Mach 2. The force is so violent it would snap a passenger airplane in half. And yet, even this gigantic parachute is still not enough for a human mission. It works for small robotic rovers like Perseverance, but a human Mars lander won't weigh 1 ton. It will weigh 40 tons or more. The parachute slows it, but only to about 300 kilometers an hour. That's still a crash. So parachutes alone cannot land humans on Mars. This is the core problem of Mars exploration. The Skycrane, how we landed Perseverance. NASA already faced a miniature version of this problem. In 2021, the Perseverance rover approached Mars. Instead of landing directly on legs, NASA did something unbelievable. They lowered the rover on cables from a flying rocket platform. The system was called the Skycrane. A rocket-powered descent stage hovered above the surface while gently lowering the rover. Then, after touchdown, the flying platform deliberately crashed itself far away. It worked perfectly. But now imagine scaling that not for a rover, but for an apartment-sized spacecraft carrying human beings. The forces become enormous, and this is where future Mars missions change completely. Supersonic retropropulsion, the Starship method. The leading solution today is something radically different. Instead of fighting Mars' thin atmosphere, engineers plan to ignore it. The spacecraft will fall most of the way down, then ignite engines while still supersonic, This is called Supersonic Retropropulsion, rockets firing directly into the oncoming airflow. It sounds impossible. For decades, engineers thought the exhaust would destabilize the vehicle. Then SpaceX tested it with Falcon 9 boosters. Every time a booster lands on Earth, it performs a smaller version of a Mars landing. The giant spacecraft Starship is designed specifically for this. It won't land on parachutes at all. It will belly flop through the atmosphere to create drag, slow itself, then rotate vertically at the last seconds, and land entirely on rocket engines, a powered landing on another planet. What the crew experiences inside the cabin, the astronauts won't see the dramatic maneuvers, they will feel them. First, violent shaking during plasma entry, then sudden quiet under parachute, then free fall, and finally the engines ignite beneath them. The entire spacecraft roars. The seats vibrate, dust begins to swirl below. For the first time in human history, humans are hovering over another planet. Then contact, a gentle thud, silence. After a 70 million kilometer journey, humanity has landed on Mars. Why this is the most important part of the mission? Here's the reality. Getting to Mars is hard, but landing is harder. Because unlike Earth orbit missions, there is no rescue, no backup, no second chance. Every system must work perfectly autonomously on the first try. This single moment determines whether the entire Mars mission becomes a triumph of civilization or a tragedy. And that is why engineers spend decades designing just 7 minutes. In the next episode, we'll follow what happens immediately after landing, how astronauts will survive their first night on Mars, build power systems, and create a real base on another world. If you want to continue this human journey to Mars, subscribe and join the mission. Because for the first time in history, we're not just visiting space anymore.